Hi everyone! So in this video, we're gonna determine the greatest common factor of the monomial. So what we're gonna do? So express each monomial as the product of its prime factors. Okay, let's have the first example. So the given monomials are 4a cubed x cubed y cubed, 24a squared x y to the fourth, and 36a to the fourth x squared y squared. So the first monomial is 4a cubed x cubed y cubed. Okay? So as I said earlier, express each monomial as a product of its prime factors. So where 4 is equal to 2 times 2. And then a cubed, so meaning a is multiplied 3 times by itself. Or that is a times a times a. And then x cubed, x times x times x. And then y cubed, it's y times y times y. Okay. Then the second monomial is 24a squared x y to the fourth. So now recall your elementary lesson using the prime factorization. So get the prime factors of 24. So 24, okay, let's use the 6 and 4 as its factors. So where 6 is a composite number, so what are the prime factors of 3? 6. So it's 3 times 2. And then 4, it's 2 times 2. And then get all the prime factors. So 2, another 2, another 2, and another 3. So there are 3 2's and 1 3. And then in here, just align all similar factors. So remember, there are 3 2's. So 2 times 2. So times 2 and then times 3. Okay, so a squared. So there are 2a. So a times a and then times x. Then y to the fourth. So y times y times y times y. Okay, the third monomial is 36 a to the fourth x squared y squared. So 36 is, okay, factors of 36. So let's use 9 times 4, where 9 is equal to 3 times 3, and 4 is equal to 2 times 2. So there are 2 2's and 2 3's. So again, align all similar factors. So 2 times 2, and then times 3 times 3, okay? And then a to the fourth, so a times a times a times a here. And then x squared, x times x, and then y squared times y times y. Okay, let me erase this first. Okay, so then next, inspect the prime factors of each monomial. Okay, so again, the GCF is the greatest or the greatest common factor, a factor which is common to all. Okay, so let's inspect the factors. Okay, so in here, 2 is common. And also here, and then a here is also common. Another a, and then the x, then y, and y. Bring it down. So 2 times 2 times a times a times x times y times y. and then simplify. So 2 times 2 is 4. A times A is A squared. And then X. Then Y times Y is Y squared. So this is the greatest common factor of these three monomials. Now, what is the shortcut now to determine the greatest common factor? So of course for 4, 24, and 36, 4 is common. Now, for the variables, take a look on the exponents of A. In here, it's A cubed, here A squared, and then in here is A to the fourth. So just simply get the least exponent of A. So which is A squared. Next, for the variable X. So in here, it's X cubed. Here is X to the 1. And in here is X squared. So the least exponent of X is 1. So get X raised to the first power. And then for the variable Y, so in here it's Y cubed. In here, Y to the fourth. And in here, Y squared. Again, the least exponent of Y is 2. Or that is Y squared. So this is the greatest common factor. Then, Here 25, A raised to the power of 3m plus 2, B raised to 4n plus 1, and 15, A raised to the power of m minus 1, B raised to 2n plus 3. Again, guys, just express each monomial as a product of its prime factors. So let's take the first monomial. So which is 25, A raised to the power of 3m plus 2. Then B raised to the power of 4n plus 1. So again, 25 is equal to 5 times 5. How about for A raised to the power of 3m plus 2? Now, let's work backward and apply the one of the laws of exponents, which is the product rule. It says in there, when you're multiplying power with the same base, just add exponents. So, meaning, with A raised to 3m plus 2 can be expressed as A raised to the power of 3m times A raised to the second power. Okay, let's check. So A raised to 3m times A squared is equal to A raised to 3m plus 2. Okay? Then, next. For B raised to the power of 4n plus 1, that one can be expressed into B raised to 4n times B raised to the first power. Okay. The other monomial, which is 15, A raised to the power of m minus 1, B raised to 2n plus 3. So again, 15 is equal to 5 times 3. And then for A raised to the power of m minus 1, that one can be expressed as A raised to the power of m times A raised to the power of negative 1. Okay? Then, for B raised to the power of 2n plus 3, that one can be expressed as B raised to the power of, 2n. Okay. B raised to the power of 2n times B raised to the third power. Okay. So, get the common prime factors. So, in here, 5 is common. So write it down. For a raised to 3m and a raised to m, as I said earlier, just get the least exponent of the same variable. So that one, since m is less than 3m, so get a raised to m. For a squared and a raised to -1, get a raised to -1. For b raised to 4n and b raised to 2n, of course, 2n is less than 4n. So get b raised to 2n. And then lastly, for b raised to the first power and b raised to the third power, so get b raised to 1 since 1 is less than 3. And then multiply the common prime factors. So 5. Then a raised to m times a raised to -1. So apply the product rule. So a raised to m times a raised to -1. So just add the exponents. So that is a raised to the power of m minus 1. And then b, so 2n plus 1. Or that meaning b raised to 2n times b, that is since they have the same base. Add the exponent, so b raised to the power of 2n plus 1. So now, this is the greatest common factor of the two monomials. Chanan!